the spectra that I was showing before out to 2.5 micrometers. That's the most common spectral region. When asteroid spectra are taken, that's usually how far we go out. There's a lot of instruments that can do it. It's very convenient, but it hasn't given us much for Ceres. So there are instruments that can get us a little bit further. So this would be the Ceres spectrum plot, image. So this just shows Ceres alone, and it takes the wavelength region from the previous plots. It expands it a little bit further out to the right, and it really zooms in on the y-axis. So you can see that we're talking about differences of, where it'll reflect 7% of the light instead of 9% of the light. So we're really talking about really stretching the image, as stretching the colors, so to speak. And it turns out that there is a little bit in there if you really stretch it out. We see, again, at about 1 to 1.5 micrometers, there's kind of a dip there. We think that's due to oxidized iron. Maybe something like magnetite is the mineral that people might be familiar with on Earth. Although, as I'm not a rock hound, I don't know how familiar people might be. I think magnetite is the black little specks. If you go to the beach and you have a handful of sand, I think the little black specks are magnetite. There's a gray region, and this is a very important region. That's where you find absorption features and these bumps and wiggles due to water. And unfortunately, because of water in the Earth's atmosphere, it's very hard to get that data. In that gray region, we actually had to use data from a satellite in space to get that. And we do see evidence of OH on Ceres, probably like these kinds of clays that Katie was talking about in some of these meteorites. And then there are a couple of other features in here again. Some brucite there is a magnesium hydroxide, and that's something that's not really found much in the meteorites, but we do certainly seem to find it on Ceres. And then two other features that we think are due to carbonate minerals, which makes Ceres one of only a few places where we've found carbonates. I think other than Earth and Mars, it's Ceres. So this starts to let us put together an idea of what is present on the surface of Ceres, and then that lets the geochemists go ahead and say, okay, how do you make these things? What kind of environment do you have to make something like brucite, to make things like carbonates? And also, to go back and rule out, okay, it doesn't look like Vesta. We think we know what happened on Vesta. There was some sort of melting of rocks and maybe some lava coming out. And we don't see those minerals on Ceres, so that suggests that didn't happen on Ceres. Again, consistent with what we see in the meteorites, at least some of the meteorites. But we are pretty sure we don't have meteorites from Ceres itself, so we're missing that link that we had for Vesta to be able to say, to put it all together. So Dawn is really going into new territory in that sense.
Why is it so exciting and so different that Ceres has all this stuff in the IR? How does it compare to other asteroids?
There do seem to be other large asteroids that have similar spectra to Ceres. We don't have nearly as much data, but if you follow the chain of logic and you say, okay, Ceres' surface is the way it is because of its history, and its history is that it has this big ice shell over a rocky core, then you might think this has happened a few times in the largest asteroids. And that starts to then make Vesta look like the odd duck.